For the next example, for the beam loaded as shown by double integration method, determine the deflection and slope at B, at the center when A is L over 2, and at the center when the uniform load covers the entire span, EI is constant. So this is the situation, and we use this situation to derive the mid-span deflection when the load covers the entire span. And I think you're familiar with it if you're already through. But if it is your first time, you do not know yet the maximum deflection. And because that's common when the entire beam is, simply supported beam is covered with uniformly distributed load. So first, let's solve for the reactions, AY and RB. We'll just solve AY. So moment B 0, or summation moment C rather 0, equals AY times L minus W times A, quantity A over 2 plus B. So minus WA times A over 2 plus B. So AY equals WA over L, quantity A plus 2B over 2 over 2, or WA over 2L, quantity A plus 2B by simplification. So we have a sectioning here to set up the moment equation. Let's call that X. So that the moment equation is continued up to this section here, then we have to extend the loading and counter it by an upward equal loading. So therefore, the moment of this section is AY. So AY double prime equals WA over 2L, quantity A plus 2B times X, plus this moment of this loading, which is W times the length is X minus A. The moment arm is X minus A over 2. So W times X minus A over 2, then minus W times X over 2. So hoping that later we directly set up the moment equation, W over 2 X minus A squared, then this one minus W over 2 X squared. So simplifying, AIY double prime equals W A over 2L, quantity A plus 2B times X, plus W over 2 X minus A squared minus W over 2 X squared. Integrating once, EIY prime equals WA over 2L, quantity A plus 2B, X squared over 2, so it becomes WA over 4L, plus W over 6 X minus A cubed minus W over 6 X cubed plus C sub 1. Then integrate further, X cubed over 3, so this becomes WA over 12L, quantity A plus 2B, X cubed plus W over 24X minus A to the fourth minus W over 24X to the fourth plus C sub 1X. Again, there is no C sub 2 because when X is 0, the deflection at A is 0. C sub 2 divided by EI is the deflection at A, while C sub 1 over EI is the slope at A. Remember that. So when X is L, C sub Y is 0. So 0 equals W over 12L, quantity A plus 2B, L cubed plus W over 24L minus A to the fourth minus W over 24L to the fourth plus C sub 1 times L. So solving for C sub 1, we transpose the negative becomes positive divided by L. So this becomes WL cubed over 24. Then minus WA over 12, quantity A plus 2BL, because this is supposedly L squared. L cubed over L squared is just L. Then this one divided by L, W over 24L. Then take note that L minus A is B, so that's why I replace it with B to the fourth. So that's the value of C sub 1. There's no need to simplify because we cannot combine like terms anymore. So C sub 1 is W over 24 L cubed minus WA square, distribute A square L over 12 minus WABL over 6, distribute this, and minus WB to the fourth over 24L. So that is C sub 1. So C sub 1 is W over 24L, quantity L to the fourth minus 2A square L square minus 4AB L square minus B to the fourth. After we factor out W over 24L, so we have L to the fourth. So here we have 2A square L square, you check. Then 4AB L square, then minus B to the fourth. So we factor out W over 24L. So that is C sub 1. EI delta B therefore is WA over 12L. In this equation, A plus 2B, X is A, so A cubed minus plus this value which is 0 minus W over 24A to the fourth, then plus C sub 1 is WA over 24L, quantity L to the fourth minus 2A square L square minus 4AB L square minus B to the fourth times L. So distribute and factoring out WA over 24 EIL, then we'll have 2A cubed A plus 2B minus A cubed L plus L to the fourth, just copy here, then minus 2A square L square minus 4AB L square minus B to the fourth. Then for when A is L over 2 and B is L over 2, substitute here. So delta B when A is L over 2 is W L over 2 over 24 EIL, quantity 2 L over 2 cube, L over 2 plus 2 times L over 2 minus L over 2 cube times L plus L to the fourth minus 2 L over 2 square L square minus 4 L over 2, then B L over 2 L square minus L over 2 to the fourth. So simplifying inside the brackets, delta M is WL over 48 EI, quantity 3/8, this is 3/8 L to the fourth minus L cube over 8, L to the fourth over 8 rather, plus L to the fourth minus L to the fourth over 2. This is L to the minus L to the fourth, then minus L to the fourth over 16. So combining like terms, cancel this. The result would be delta B at delta B when A is L over 2 and B is L over 2 is negative 5WL to the fourth over 768 Ti, and it is represented by this loading situation here. So that's the deflection at midspan. So if the entire span is covered with uniform load, then we expect that the deflection at midspan will be double this value. So we multiply this by 2, and that's the maximum deflection at midspan when the beam is loaded entirely with uniform load. So it is negative 5WL to the fourth over 384 EI for that situation. And I hope that you're familiar with this situation. So that's it for this problem.